Hi, I'm Barbara Andrews, and in this session, we'll explore how great AI agents aren't built once and left alone. They're continuously tested, measured, and improved. As teams deploy agents into real workflows, new prompts, tools, and data, it can all change how those agents behave. Without structured evaluation, it becomes difficult to know which changes actually make the agent better and which introduce new problems. In this section, you'll learn how to evaluate and optimize AI agents through structured experiments using defined test cases, evaluation criteria, and iterative experimentation. Teams can compare prompt and agent versions in a repeatable, data-driven way, ensuring each update improves accuracy, reliability, and real-world usefulness rather than relying on guesswork. If you want AI agents that actually improve instead of randomly changing, structured evaluation experiments are essential. Here we have the recipe. Measure quality. Does the answer solve the user's intent and stay grounded? Cost, token and model expenses, and performance, speed of response. Then deliberately experiment with model options, prompt refinements, and configuration tweaks to see which version performs best across those three dimensions. Consider a customer support assistant being tuned to answer product questions. By testing GPT-4 versus GPT-4 Mini, along with several prompt variations, the team can discover a version that still provides accurate answers but reduces latency and token costs, improving both user experience and operational efficiency. If your AI agent changes every time someone tweaks a prompt, you need a controlled experimentation loop to reliably improve it. The workflow shows how to run structured evaluations with Git, create a separate branch for each experiment, store test prompts for reproducible runs, execute the agent to capture outputs, and record results in a shared scoring file before comparing variants and merging the top-performing approach. Imagine testing two versions of a Copilot assistant for travel planning. One branch might test a new model variant, while another tries enhanced prompts. Running the evaluation script and scoring responses quickly reveals which version gets clearer, more helpful answers. So teams promote the strongest version instead of guessing. A reliable operating pattern is to treat prompt experiments like code experiments, isolate changes in branches, store repeatable evaluation prompts, and compare results systematically so improvements remain measurable and traceable. If your team wants AI agents that improve predictability instead of uncertainty, consistent evaluation is essential. Here we see how to create reliable scoring for agent responses, define clear rubrics with concrete examples for each score level, run calibration sessions so evaluators interpret their scores the same way, and perform inter-rater reliability checks to ensure results stay consistent over time. Remember to align evaluation criteria with automated evaluators or human-in-the-loop workflows, allowing teams to move from manual judging toward scalable, repeatable assessments. Imagine reviewing responses from a customer support AI agent with structured rubrics and aligned evaluators. Multiple reviewers can score answers consistently, revealing whether updates actually improve intent, resolution, clarity, or accuracy. The advantage is dependable evaluation signals that guide agent improvements rather than subjective opinions. In this demo, we're going to focus on prompt stabilization and regression testing, which is essential for turning generative AI from a clever prototype into a reliable production system. As prompts evolve, even small changes can unintentionally degrade quality, consistency, and safety. You'll see how to treat prompts as first-class assets, versioned, tested, and compared over time, so you can confidently improve behavior without breaking what already works. This is a cornerstone of Gen AI Ops and a key skill in AI-300. Because production-ready generative AI depends on measurable quality, repeatability, and trust, not guesswork. Before an agent is versioned, deployed, or connected to tools, there's one step that separates experimentation from engineering: discipline, validating how the model actually behaves. In this demo, I'm going to be using our Azure AI Foundry's chat playground. And in this, we're going to be using it so that we can get prepared for pre-production validation environments where we can shape behavior to reduce ambiguity and refine prompts before they become part of a versioned agent or code-based workflow. Foundry playgrounds are explicitly designed for rapid prototyping, prompt engineering, model comparison, and technical validation before production. We'll start by stabilizing a prompt. Then we'll do something even more important. We'll test whether a future prompt change quietly breaks the behavior we've just improved. That second step is the bridge to prompt regression testing, the practice of comparing prompt versions against the same test set to catch unwanted changes before deployment. So this demo has two parts. First, prompt stabilization, which means improving a prompt until the model behaves consistently across related requests. And second, prompt regression awareness. This means testing whether a new prompt version causes unintended behavior changes that we rerun the same inputs. This matters because in generative AI, the prompt is part of the system behavior, and small wording changes can improve one answer and slightly degrade 5 others. Prompt regression testing is specifically about running the same fixed inputs against prompt versions and comparing the outputs with regressions. So the chat playground is where we're going to learn good behavior like this, and we'll begin protecting as we go. Here are the 4 best practices to keep in mind. 1 is you want to test multiple related prompts. Second, you want to change one thing at a time so you know what actually caused the improvement. Also, you want to optimize the prompt before escalating the model. And lastly, once behavior is stable, you want to treat this prompt like a versioned asset so that we can compare it and protect it over time. So these principles align with some of the common prompt versioning and regression testing practices described in our current large language model testing. So we're going to start first with prompt stabilization. And what we're going to do is we're going to go into our system instructions here, and we're going to give it the first set of instructions. And that is you. You are an outdoor trail assistant for beginner hikers. Give helpful advice. So we'll start by really just saying this is deliberately a weak system instruction. It sounds reasonable, but it's not agent ready. There's no structure. There's no explicit handling of uncertainty or no consistent rules. This is where many teams begin, and this is exactly why stabilization matters. So we have a couple of rounds of prompts, and we're going to use some which you may have seen in a previous demo. But the first one is, I'm new to hiking. What should I bring for my half-day spring hike? And when we run this, it's going to give us some useful advice back. And our assistant is going to go through, and we're going to see the results on this in a moment here. And notice our results here. So it gave us similar information, I think, as before about our half-day hike. To bring essential-wise, dress in layers, wear socks, have sturdy footwear. It's really kind of just going through the things that it thinks that we might need, and it's helpful, but this is one of 2 more prompts that we're going to run here. So let me see some of our other options so we can see the results there. And then I'm going to run this one. And this one is one of the ones we ran in a different demo. It's a steep trail okay for beginners if the weather is cold and windy. And again, we can see the results here. Why it's harder than it looks. Make sure you have the best information set here so you know you can ask it to maybe look over and give us slightly different answers and maybe not the answers that we want to have. And so we keep this more structured by working with it a little bit. And now I'm using these multiple related prompts to kind of show a good prompt design should survive more than one example, because real users rarely ask the same question that we're testing for. So I want you to notice that when we see the output, notice what happens here. The tone may shift, the structure may vary. One answer may sound more confident than another, and uncertainty may be handled inconsistently. So the answer may be helpful, but what we want is we want it to be predictable. So that's where the prompt stabilization comes into play. So now we're going to try version 2 of our prompt, and we'll put this one in. This gives a little bit more detail, and I'll go ahead and I'll apply it, and we can see with this one. Let me continue this. So we are giving it a little bit more info now. And so what we're telling it here is that you're an outdoor trail assistant for beginning hikers, and we'll give it some rules, give us concise recommendations, include safety considerations, and avoid making assumptions about conditions. So I'll ask it one of the questions. And as we asked earlier here about what we should bring on a half-day spring hike, now we're creating a strong prompt version here, and we haven't changed the model. What we've done is we've changed the behavior. This is the essence of prompt stabilization, making the model easier to predict by clarifying expectations. And as we can see, it's already a little bit better. The model has now a little bit more direction, but it still doesn't fully have control over here with the response shape. So that is the next step here, but we can take some additional steps, which we're going to do now. Here's version 3, and we're going to try this prompt here as our instruction, and we'll go ahead and apply it. This one you may have remembered from a little bit earlier. It's similar to it. And we're telling it you're an outdoor trail assistant for beginning hikers, and we want the response to have a recommendation, 1 sentence. Why it matters is what to bring, watch out for, and then some rules. Be explicit about uncertainty. Do not invent trail or weather conditions, and keep the responses to 120 words. So now when we try some of our same questions as before, we're going to notice that there is a difference now in our responses. So it does the recommendations, why it matters, what to bring, and we see it's kind of reached its 120 characters there with what to watch out for. So a little bit more controlled is this response. And then if we ask it what we should pack, notice it's giving us a result here. We'll give it a moment, and it's starting to feel a little bit more like engineering, because what we've defined the audience, the response structure, the safety, the posture, uncertainty, handling, and length. So it's no longer just a prompt. It's really becoming a candidate for an agent instruction. And notice the responses here are easy to scan. They're more consistent. They're cleaner. They're clearer about assumptions. And that's prompt stabilization in action right here. So this maps directly to the Foundry agent design. What I'm validating here is that the part that later becomes a version system instruction, an agent behavior definition, and eventually something that can be stored, reused, and deployed. Foundry Agent's lifecycle guidance emphasizes building, testing, and iterating before publishing. This is exactly what this stabilization step supports. And now we're going to transition into regression testing. This is our second phase of this demo, and it shows us our second problem. Let's say this prompt is good enough to version. What happens next month when someone edits it and makes it more helpful? How do we know it worked? It didn't quietly break the behavior that we have just established. That's where prompt regression testing comes in. So what is prompt regression testing? It means taking the same fixed input set and running it against a new prompt and checking whether the behavior got worse in ways we didn't intend. So the goal is not more exploration anymore. The goal is change detection, and industry guidance is going to define prompt regression testing as comparing new prompt versions to a baseline across a standard test data set so we can catch quality drops before deployment. So we want to establish a good baseline, and what we're going to do is we're going to use our baseline is our version 3 prompt. And so that will be our baseline. And then we're going to use that same 3 prompts we already tested, our mini regression test. So now what we're going to do is we're going to change it out to a version 4. Someone edited the prompt to make it feel more natural and engaging. And on the surface, as you look at it, it sounds like an improvement. It says you are a friendly outdoor assistant for hikers. Be conversational and engaging, offer extra advice and suggestions wherever possible, and then use natural, engaging formats. And what we've actually removed is we've removed the structure. We removed that uncertainty rule that if it doesn't know, to let us know. And we removed the no invention rule. And we also have here the response length constraint is now gone. So this is exactly how regressions happen. So now when we return some of our prompts and rerun them, the steep trail, okay for beginners one, notice what happens here, especially if it's weather's cold and windy. What we're noticing now is we have the exact same input, which is important for testing regression, whether you're changing the user version or only the prompt version. But after the response, what you'll see here is that this signals regression. Did structure drift? I'm going to say it did. I don't have the same structure. Its uncertainty is less explicit here. Did the model start sounding too confident? Is it more verbose or inconsistent? And yes, this is regression here. Even if the answer still sounds really useful, it's still regression because we lost a lot of our structure. So this is the heart of prompt regression testing. A prompt can be better in one dimension like tone, while getting worse in the dimensions that matter more for the product: consistency, predictability, safety, and output shape. If we make a change to our prompt, it should be treated like a code change where we have versions that we keep track of and we can reuse test cases, and we don't trust a single good answer. And we keep testing it and stress testing it, trying to get the best prompt for our instructions to get the most consistent outcome. So what we did here may look simple, but it's foundational to building reliable AI systems. In the first half of the demo, we used the chat playground to stabilize behavior, tuning a vague instruction into something more structured, safer, more predictable. And in the second half, we used the same environment to see why that's not enough. A prompt that works today can quietly degrade tomorrow if changes aren't tested against a known baseline. This is exactly the problem prompt regression testing is designed to solve. So the big takeaway here is prompt stabilization is how a prompt earns the right to be versioned, and prompt regression testing is how it earns the right to stay in production. Thank you so much for your time, and I hope you enjoyed this demo. If you've ever wondered how teams confidently improve an AI agent's prompts instead of relying on guesswork, this exercise shows the workflow. You'll step through a structured experimentation process, setting a baseline for the current prompt, creating Git branches to test variations, and measuring response quality to determine which update actually performs better. Working with the AdventureWorks Trail Guide agent, you'll experiment with prompt improvements, compare results across versions, and identify the variant that delivers the strongest outcomes. By the end, you'll have practiced a repeatable, evidence-driven method for evolving prompts, the same disciplined approach teams use for safety role prompt improvements into production AI systems. Now it's time for our knowledge check. Question 1. Your experiment shows GPT-4 Mini reduces costs by 75% while maintaining an average quality score of 4.1, where the threshold is 4.2, and improving response time by 32 to 18 seconds. What should you do? Answer: document the trade-offs and seek business stakeholder input on whether cost savings justify the quality reduction. Question 2. What is the primary reason for organizing agent optimization experiments into separate Git branches? Answer: to isolate specific changes and attribute performance differences to individual modifications. You've now seen how structured evaluation turns generative AI from something that changes into something that improves. By defining clear metrics, running controlled experiments, stabilizing prompts, and using regression testing, teams replace intuition with evidence. This is the heart of our Gen AI ops. Every prompt change is intentional, every improvement is measurable, and every regression is detectable before it reaches users. With these evaluation and optimization practices in place, you're equipped to evolve AI agents with confidence, delivering systems that get better over time, not by accident, but by design. Over the course of this learning path, you moved beyond simply building AI agents to operationalizing them with a disciplined Gen AI ops approach. You explored how to plan and architect a Gen AI ops solution, manage and version prompts using Microsoft Foundry and GitHub, and improve agent quality through structured, measurable experimentation. The key takeaway is this: powerful agents aren't the result of a single prompt. They are the outcome of thoughtful design, controlled experimentation, and continuous improvement. By applying these practices, teams can transform AI agents from interesting prototypes into reliable, scalable systems that deliver consistent value to real users. Thank you for watching. Next, keep building your Gen AI ops skills. Continue on Microsoft Learn at aka.ms/learn for more ready-to-use hands-on learning. And don't forget to check out AI Skills Navigator for curated recommendations that match your role and goals. See you in the next video.